this video I will doing the homework 11 of EL6303. Problem 2. Let's see the question. It is suggests that the following function of V. The question wants us to know if these functions can represent the autocorrelation function of WSS statistic process by setting V equals to tau, or a spectral density function by setting V equals to omega or both. So let's do the question now. We know that RT is an autocorrelation of a real WS statistic process XT if it is even. RT should be even and R tau less than equals to R0, and its Fourier transform is non-negative. If S omega is the power spectrum of WS process, then it should be non-negative. So let's see the first one. Fv is equals to e to the minus absolute V. Let's consider the autocorrelation first. We know this F minus V is equal to Fv, so this is even. So this should be tau. And e to the minus tau less than equals to e to the minus 0. And also the Fourier transform of this part is equals to 2 alpha over alpha square plus omega square, which is non-negative. It's absolutely non-negative. So Fv equals to e to the minus absolute V may represent the autocorrelation. And next, let's see the power spectral. E to the minus absolute omega greater than or equals to 0 is non-negative, so it can represent the power spectral. Let's see the second one. Fv is equals to sine V squared over V squared. The first, let's also see the autocorrelation. F minus tau is equals to sine tau square and over tau square is equals to, this is equals to F tau, so it is even. And F sine tau square over tau square less than equals to this part. And the Fourier transform of this is we know from the form, which is non-negative, so it may represent the autocorrelation. And the sine omega square over omega square is non-negative, so it may represent the power spectral. Now see the last one. Fv is equal to 1 when V less than equal to alpha, and is equal to 0 when V greater than alpha. So we have Fv is this figure. Let's see the Fourier transform of this is 2 sine omega alpha over omega. We cannot prove that this part is non-negative, because sine have a negative part and non-negative part here, and so it's not it cannot represent the autocorrelation. And let's do this calculation. S omega is equal to from the definition, and Rv is equal to 1 in this range, so we can get the result that the Fourier transform is this. And from this feature we know that F omega greater than or equal to 0, so it can represent the power spectrum. So this is homework 11.